All right, so hello and welcome to our next presentation in the series of our tutorials dedicated to how to use HAL for machine learning. Today, I'm very happy to introduce Dr. Dawei, who is going to talk about one particular tool that is already deployed on our system called H2O. This tool comes with a collection of machine learning models which are ready to deploy and use right away without any coding. And there are many use cases where this tool can be used directly without the need of writing a single line of code. So Dawei, thank you very much for your willingness to present about this tool, and this is all yours.
Good afternoon, everyone. Welcome to join this training section. Today, we will introduce some basic knowledge about AI and machine learning and deep learning, and how to start your machine learning training section with no coding requirements on HAL system. Now, let's get things started with some very popular terminologies. First is AI, the artificial intelligence. So artificial intelligence was born in the 1950s when many pioneers started asking whether the computers could be made to think like a human. A concise definition of this field will be described as follows: the efforts to automate intellectual tasks normally performed by humans. And time passed to 1980. The machine learning rise from the question, could a computer go beyond what we know how to order it to perform a task and learn on its own way how to perform a specific task. The field of machine learning focuses on the study and the construction of a computer system that can learn from data without being explicitly programmed. Machine learning algorithm and technique are used to build model and to discover hidden pattern and trend in the data, allowing for data-driven decision to be made. Deep learning is actually a specific subfield of machine learning, which gets more and more popular since 2010. The deep learning is a new take on learning representation from data and put an emphasis on learning consistent layers of increasingly meaningful representations. So the deep here is now mean any deep thinker or deep understanding rather than the deep consistent layers of representation of features. This data science is an interdisciplinary field. As we can see, it composed of domain science, the mathematics, and computer science. To acquire all these requirements has a very high barrier. But the good point is, this is also it's a very not that high barrier to entry the field. As long as you have domain science and computer science and mathematics, we can all find our own path and specialty to research on the data science and all its subfield. And as we all know, machine learning, deep learning are very popular right now since 2010. But why now? I mean, the two idea of deep learning, of a computer vision, the convolution neural network, and the back propagation were already well understood in the year of 1989. And the long short-term memory, the LSTM algorithm, which is fundamental to deep learning for the time series, was developed in the year of 1997. That barely changed after that. The reason is for this blooming of machine learning and deep learning has three causes. The first one is the hardware. After 2010, there's high performance GPU and the TPU being introduced to the research, which greatly improve the efficiency of computation tasks. The second cause is the data set. Due to the blooming development of internet, the large data set collected from the internet become feasible. So this provide all the basic material for all the machine learning and deep learning research. The last but not the least is the algorithm advance. So recently we have a lot of progress made for activation functions and optimization schemes, which greatly improve the efficiency and the performance of the machine learning and deep learning research. Today, what we're gonna talk about the tool is called H2O. The H2O is actually it's an open source product of H2O.ai, which is a company behind the open source machine learning products like H2O. This company aimed to make machine learning easier for all. That's why we described earlier that using these tools, you do not need to have any coding or programming experience. Every model is already built up there, and you can use that for your research very easily. H2O itself is an open source, Java-based, in-memory, distributed machine learning and the predictive analytic platform, allowing you to build and productionize machine learning models. This H2O API contains supervised and unsupervised model in R and Python, as well as a simple-to-use web UI called Flow. This is a snapshot of the H2O flow. Today, the hands-on section, we're going to use this H2O flow to perform several real machine learning cases to demonstrate how to properly start your machine learning training tasks with this tool without any requirement for coding. So now let's have some basic introduction of machine learning algorithms. The machine learning algorithm has three main functions: classification, prediction, and clustering. There are three big basic algorithms, which are K-nearest neighbor, linear regression, and K-mean clustering. They also have other common algorithms like decision trees, random forest, naive Bayes, and support vector machine, which we will have a short introduction in the following content. First is the K-nearest neighbors. So this is a classification method that an object is classified by a majority vote of its neighbors. As we can see from the right-hand side plots, when we try to classify these green dots, we will have to choose how many nearest neighbor will have the vote. when the k nearest the neighbor, the k number is 3, then we just have the vote of these 3 neighbors that we can decide this green dot will be classified into the right triangle. If the k is 5, then we can see, but based on the majority vote, the green dots gonna be classified as the blue squares. So this pretty much all about the k nearest the neighbor. This is one of the simplest classification algorithm, and the k is the constant specified by the user. The k nearest the neighbor is computationally very expensive. So how do we choose the factor k? The choosing of a factor k could be a challenge. As we can see from the right-hand side, with the increasing value of k, we can see the boundary becomes smoother and smoother as the k value increase. And yes. So let's talk about the pros and cons of the k nearest the neighbor. The pro is this method is beautifully simple and logical. The con is it may be driven by the choice of k, which may be a bad choice. Generally, larger value of k reduce the effects of noise on the classification, but make the boundary between the classes less distinct. The accuracy of the algorithm can be severely degraded by the presence of noise or irrelevant features. So it is important to review the sensitivity of the solution to the different value of k. The second common machine learning algorithm is linear regression. As we can see from the examples, this linear regression is used to estimate real values like the cost of a house, the number of phone calls, the total sales, and so on, based on the continuous variables. A linear approach for modeling the relationship between a dependent variable y, in our case, is the price of the house, and the explanatory variables or independent variables x, in our case, is the living area of the house. So we just base on the living area's house as the only features that affect the price of house, and then to perform the linear regression to if giving a house living area, the model gonna predict the house of a price. This is a supervised algorithm that learns from a set of training examples, as the price is defined by the current table on the left-hand side. Each training example has one or more values as input values and the single output values. In our case, we only have one, which is a living area, and the output is the price. So the linear regression will learn the line, the plane, the hyperplanes that best fit the training examples. Since we only have one features listed in our case, so we are trying to finding the regression line. If it's more than one features, there will be a plane and hyperplane. So as we can see, this linear regression is very simple to interpret and easy to train. The linear regression can be used as a baseline for evaluating other more complex regression models. The goal of linear regression is to find the best fit line by minimizing the sum of the squared differences between the points and the regression lines. There's two ways to solve this problem. One is called the normal equation, which will solve the theta within our formula analytically, which works very well for small feature sets. But for in the real world cases with the data set has a very large feature size, people will use a gradient descent method, use iterative optimization approach that tweaks the model parameter to minimize the cost of function over the training site and eventually converging to the optimal solution. A gradient is a slope of a function at of a specific point. The gradient of loss function is equal to the derivative of slope to the curve. As we can see from the plots on the right-hand side, this method will have an initial set of a parameter and then calculate the gradient and the slope. Based on the slope, we will move the parameter using the learning rate to the opposite direction, and then calculate the slope again. Using this method, we can gradually find out the smallest slope, where is the global minimum of the loss function as the solution of the problem. So this is a series of plots shows how linear regression works. Since we have M and B as two feature sets, so this regression will be searching the global minimum as a plane. As we can see, for each iteration, we minimize the error and by changing the slope and the offsets of the right lane, and eventually feed the optimal solution. So this is how the linear regression actually computed. The third big basic algorithm is K-mean clustering. The K-mean clustering is used to discover the structure within the unlabeled data. Clustering is a technique for finding similarity groups in the data called clusters. It attempts to group individuals in the population together by similarity, but not driven by a specific purpose. Clustering is often called unsupervised learning, as you do not have to pre-describe the labels in the data and no class value denoting the priori grouping of the data instance are given. This is a graphical view of K-mean algorithms. We have a random set of data, and we will choose the K as initial means. In our case, is K equals to 3. So this model will try to clustering this set of data into three clusters. First is that we need to set a initial point as the blue dot, green dot, and the red dots were located in the data set, and then we're gonna compute each dot closest the center point. So the first round, we can see that as step 2, the dots being colored based on the nearest center point, a centroid point, and as the step 3 is based on all the points in the same cluster, we will calculate the center point based on all the data within the same cluster, and then move the center point into the centroid of the cluster, and repeat the step 2 and 3 till the result convergence to the final solution, which can be seen in the step 4. So the final result will look like this. K-mean is as the most simple unsupervised algorithm, has its lot of merits, but there's some weakness of the K-means that we need to discuss. First is the number of cluster K must be specified in advance. The K-mean clustering is very sensitive to the initial centroid selection, which could lead unwanted solution. K-means can only handle numerical data. The algorithm may get stuck in a local optimum. This method also sensitive to the outlier and noise, which result in an accurate partition. The K-mean biggest problem is that it cannot handle the non-globular cluster or cluster of different size and densities. The figure 1, 2, 3 shows that if the data set has a different size or had a different densities, the K clustering always try to balance it out, which could lead inaccurate result. Next is naive Bayes. The naive Bayes is a simple but very important probabilistic model. It based on applying the Bayes theorem with the naive assumption of independence between the feature sets. It computes the conditional probability distribution of each feature given label, and then it applies the Bayes theorem to compute the conditional probability distribution of label giving an observation and use it for prediction. This classifies new data based on the highest probability of its belonging to a particular class. The naive Bayes learner and classifier can be extremely fast compared to others more sophisticated methods. All right, so let's start with very simple examples. Question is, should I play tennis today? The option is yes, I will go, or no, I will stay at home. And the condition is the outlook of the weather, the temperature, the humidity, and the strength of the wind. So as we introduced the probability formula, that giving a condition, the probability that I will play or not play will be decided by all these given records. As we can see from the right-hand side, we have several tables that calculate the possibility that either play will happen or not happen based on certain conditions. So if we giving a condition like if the weather is sunny, the temperature is cool, the humidity is high, and the wind is strong, and should I play tennis or not? So based on the formula, then we just compute the possibility if I play tennis, the possibility of a play tennis in a sunny day, cool temperature, high humidity, and strong wind condition. It will equals to the possibility that I play the possibility that I play the tennis, giving I play the tennis, and if it's outlook is sunny, temperature is cool, humidity is high, and the wind is strong, multiply with the possibility of I play tennis, and divided by the possibility that the outlook is sunny, temperature is cool, humidity is high, wind is strong. By using this formula, we can get a result of the possibility of a play tennis is 0.2424. And similarly, for the same condition, the possibility that I won't play tennis is above 94%. So since the chance of I'm not playing tennis today is much greater than the possibility that I will play, so the answer is been given that I will not play tennis at a very strong wind day, which is also makes sense. Following is the decision tree. The decision tree builds classification and regression model in the form of a tree structure. You will predict the value of the target variables by following the decision in the tree form from the root in the beginning down to a leaf node. A tree consists of branching condition where the values predictor is compared to a trained weight. The decision tree are prone to overfitting. So additional modification or pruning may be used to simplify the model. So as we can see, there is a very simple example. So this is a chart that have basically two features. One is the age of people, and along the y-axis is the incomes. So this decision tree is trying to classify if a person giving his or her age and income, are they going to attend the Burning Man? So as we can see, each branching will draw a line on the data set as classifier. First is the income, which is 61K. And second is the person younger than 27 and older than, the age is younger than 27, or is he older than 38? So by these three branchings, we can see we very well classify the majority of the people that did attend the Burning Man event well So only a few that people attend the Burning Man has been misclassified to other catalog. So this is basically how the decision tree works. So how can we create a good decision tree? So we need to use some measurement to decide if the branching of the tree is good or not. The measurement we use here is entropy. The entropy is a concept used in physics, mathematics, and computer science. It measures the disorder and uncertainty. As we can see from the map, that if the entity is well-ordered, neat, low randomness, low uncertainty, that a low uncertainty that will consider as low entropy. Yes, and if an entity has high disorder, messy, high randomness, you will consider as high entropy. The mathematical definition of the entropy can be described like this. For example, if we have 30 dots and we have 16 blue circles and 14 orange crosses, we can calculate the entropy by applying this formula that will give us a result of 0.99, which is almost close to 1, which because the 1 is like means totally randomness, unorderly arranged data, because in our case, the chance of me for choosing a blue circle or orange cross is almost 50% to 50%. So this is highly uncertain data set. And also let's see our cases in this chart. If we have a outlook, if we choose outlook as a branching, if it's overcast, we have 4 yes to play and 0 not to play. So it's a pure site, the completely certain 100% based on the entropy we calculate is 0, which means entropy 0 means completely certain. And for the on the right hand side, if when the wind is strong, should I play tennis or not play tennis? It's an impure set, because for choosing this one, there's a 50 chance that I play tennis and 50 chance I do not play tennis. So which make the entropy is 1. So we want to minimize the entropy, so to make the our decision as pure as possible. There are multiple algorithms that can create a tree. I will introduce 2 algorithms in our in this presentation. First is the ID3 algorithm. The ID3 algorithm will use a measurement called the information gain. So the information gain is basically calculate the entropy before the branching minus the entropy after the branching. So the construction of the decentralized tree is all about finding the attribute that returns the highest information gain. So a decision tree is built top down from a root node and involve partition the data into a subset that contain instance with similar values. So the information gain is based on the decrease in entropy after a data set is split on an attribute. Let's take a look at example. Like that's the 30 instance of a blue circle and orange crosses. The entropy parents based on our computation is 0.996, which is a highly uncertain data set. But after we branching this data set into two based on certain condition, we can see that we have 17 instances, which 13 of them are orange crosses, and 4 of them are blue cycle. And the other side is 13 instance with 12 blue circle and 1 orange cross. By compute the child entropy from both branch, and we can multiply by the ratio of the population, we can get a entropy of the children is 0.6. In other words, that the information gain is 0.38, which measures if we did a good job by branching this data set with this. We always want to try to return the highest information gain to perform the branching of this decision tree with ID3 algorithm. Another algorithm for forming a decision tree is called CART. This CART algorithm is based on compute the Gini impurity index. The Gini impurity index using for a lot of other science region. The most famous is how to measure the income differences within the country as to see if the wealth is distributed evenly or not. So the equation of Gini impurity is that okay, so basically a node of Gini attribute measure its impurity. A node is pure so that everything is evenly distributed. The Gini index is 0 if all the training instance it applies belong to the same class. So in other words, the Gini index will be 0 if a data is perfectly classified. Let's take a look of the example. If we divide the data with the condition of a chest pain. After we divide this, if has chest pain or no have chest pain, and if this person have heart disease, we can have the Gini impurity calculate by the following formula. So, how should we start build this formula? Like for the ID3 algorithm, we try to choose the highest information gain. But in our the CART algorithm, we try to find the smallest Gini impurity index. So if we have like 3 possible branching condition, which is chest pain or not, is the person have a good blood circulation, and is the person have a blocked arteries. Based all these 3 conditions, we compute the Gini impurity index as we show in here. So after that, we will choose the smallest Gini index, which is a good blood circulation, and then we will split the data based on the good blood circulation, and then we will calculate the Gini impurity again for the subset of data, and then we can choose the second smallest Gini index as the condition to branching the following level of the trees. So, yes, all the branching will give us good result. If the new leaf separate the patients better than we had before, then we will definitely branching this leaf node. But if not, we're gonna stop branching and just keep the subdata set intact without further branching. So by doing this, as we can see here, we had a decision tree made by branching the three conditions, just like this. Another question is for the numerical data. How can we branching on the numerical data? So basically, we just for example, if we consider the heart disease with the height as a weight of the patient, then we will calculate the means of each two neighboring neighboring data, and then calculate the Gini impurity, and then find out the smallest Gini impurity and use this as a divider. As for the option, option data, we need to list all the possibility of choices that and calculate the Gini impurity index and use that one as the classifier for the classifier of the subset of data. So the pros of a decision tree is very simple to understand and to interpret it. To build a decision tree require very little data preparation. It can handle both continuous or categorical variables, as we just introduced. They implicitly perform feature selection. So the cons of decision tree is they are prone to overfitting. They create a biased tree in case of unbalanced data. The decision tree is unstable compared with other popular methods. So also this is a greedy approach by decision tree doesn't guarantee the best solution. So standard decision tree are restricted by hard axis-aligned split of the input space. This is as we shown at the Burning Man example, that how is this decision tree work. After the decision tree, we can talk about the random forest. So actually, the random forest is one of the most used algorithms. As we can see, it's basically just by definition is multiple decision tree formed a forest. But where does the random come from? The random is that from all the data, we will using the bagging method to create a multiple subset with random selected features. And then based on this subset, we will build a decision tree. And each decision tree will make a prediction, or we could make a prediction of a given new data point. And then we will, the final prediction will made by an average of the prediction from multiple trees, or we can make the final decision by the majority voting. So this is a chart that each tree will give us a classification possibility, and by aggregate the prediction, we can have a very safe decision on which this data will be classified. The pro of random forest is this random forest algorithm can be grown in parallel, so it's a highly efficient. The random forest has higher classification accuracy because this random forest can treat the problem that decision tree has, which is the overfitting by random selecting subset of data. Random forest able to deal with missing values and maintain accuracy. And also this random forest can help data scientists to save data preparation time. So the cons of a random forest is it's a large decision tree in random forest can slow down the algorithm. The good job at classification, but not as good as for regression. This random forest, like a black box approach, random forest is not that easy to interpret. And the last, I think, let's talk about the support vector machine. A support vector machine is a classifier normally defined by separating hyperplanes. As we can see from the example, the hyperplane H1 does not separate the class, and the hyperplane H2 does separate the class, but only with a very small margin. So H3 hyperplane separates the data and has a maximum amount of the margin, which is the optimal solution for this classification. So the examples that closest to the optimal hyperplane are the support vectors, which is this this method's name come from. The margin phi of the separator is the distance between the support vectors. So this is how the support vector machine algorithm works. So we will start with a random line of the equation with since this is a two-dimensional case, the equation will be ax plus by plus c. And then this will draw a parallel line with the equation ax plus by plus c equals to 1, and the ax plus by plus c equals to -1. And then we will pick a large number, like time 1000, pick a learning rate, and pick expanding rate. Then you will do the repeating by picking a random point. If the point is correctly classified, then we will do nothing. And if the point is blue, but the a plus p and the bq plus c is larger than 0, then we're going to move the parameter a, b, and c by a small learning rate with current the current location of the point. If the point is red, but it was classified within the blue region, then we will add this small learning step to the other direction. After that, we're going to multiply the A, B, C by 0.0.9 with expanding rate. After this iterative calculation, we will eventually find our line going from a random line to a perfect line that separate the two classes with a maximum margin. And SVM sometimes can use a kernel transform to transform nonlinearity separatable data into a higher dimension where a linear decision boundary can be found, which called the kernel trick. This is an example of this example that first we can now find the linear separators that can separate the black dots and the blue squares. But if we apply a transformation, then z equals to x squared plus y squared. Then we transform the classification from x to y to z. Then there is a very clear separation, and then we can use the previous support vector machine algorithm to find the optimal hyperplane, and then we will transform back to the original plane. So as we can see from the chart, that will give us a optimal solution for this data set. So this plot shows a very good example for all these three different separators works on the same case. The cross is the X marks on the map is cows, and the dots is wolves. How can we separate these two by building a fence? So we can see that using SVM, we can have a very smooth and clear separators between the two classes. While the logics and the decision trees, logistics cannot do the job. It's just a very hard, like a binary divider, and the decision trees can do the job, but we can clearly see if a building fence with this decision, it will waste a lot of material, because this also classification using of linear straight lines, rather than the linear classifier that the support vector machine can achieve. So the pros of supporting vector machine is the training is relatively easy. There's low local maximal, unlike the neural network. The SVMs has a regularization parameter, which can help avoid overfeeding. It's very effective in high dimensional space. The drawback of the support vector machine is for classification, the SVM is only directly applicable for two classes tasks. The SVM that do not directly provide probability estimate. The parameters of a solved model are difficult to interpret. Long training time and will be expected for large data set. So, and finally, choosing a good kernel function can be very tricky and affect the efficiency of the algorithm. All right, so I think we use 1 hour describe all the algorithms and the background knowledge. Now it's the hands-on time. we already have a reservation prepared for today's training session, which is called UI/UC under Scratch 21. And so right now, all the people that still with this session can try to open the Open on Demand. I will start to show the case. Yes, and also I need to note that we recommend to use a web browser, either Firefox or Chrome. If you're using Safari, which could cause some problem that we cannot easily fix. So let me start to share with this is the main page of our HAL on Demand main page. Let's click the interactive apps and select the H2O AI on Red Hat 8. This is a page that we will launch our job. The runtime in hours, I haven't used HAL yet. Do you know how I can create a home directory? Oh, if you haven't used HAL before, you need to use terminal SSH to log on HAL system first, which will create you a home directory. And then you can use this HAL on Demand.
Sorry, could you repeat that again? Because I'm also getting this error, home directory not found.
Yes, it's I think Vlad already typed the SSH command already in the chat. And okay, I will choose like the runtime with 2, and the reservation name is UI/UC 21, and then click launch. You will be bring into this section. My session is already launched for before, and if you just so where currently the H2O AI this is already running. After you just hitting the launch, you will take a short while, maybe 1 or 2 minutes. If it's get too long, you can just let me know, and there will be we can figure something out. But it should be within 1 or 2 minutes. Then you will click connect to H2O AI. We'll leave this page. And if the first time you try to open this, the first time you open this H2O flow could cause sometimes, but still a couple of minutes at most. It should be within 1 or 2 minutes. The reservation name is UI/UC under Scratch 21. So
is it okay because I didn't include the reservation name and got in at this stage?
It's okay. It's totally fine because the H2O actually have 2 versions. One, we are providing the community edition, which is only for CPUs. So it's using very little amount of resources. So using the reservation or not, as long as it works, it's totally fine. And yeah, what we can see here, this is a very like a MATLAB or Jupyter notebook alike the UI interface. So something I want to show you is that this one from the admin, you can check the cluster status, that what's the version, the starting time, what's the node, and this is the status of of this virtual cluster that we create with H2O AI. And there is a very funny called water meter. Will show the CPU usage. In my case, I assigned 64 CPU cores with my session, and this is how the CPU usage status. And then something I want to show first, I want to show the user is you can view some example flows. From the help tabs, we can see there is a multiple examples. Let's see the deep learning MNIST. We will load the notebook. This has a very detailed description of this notebook about the deep learning terminology and how to get started and how to parse the data, and all the all the commands are showing here accordingly, right? After this session, if you still have interesting to get know more about this H2O flow, you can start from here. This is a very, very good place to to start. And let me start a new flow. Let's go back. Okay, maybe I will re-log in to get rid of previously. Here is the instance of command that you normally use. Give me a second. Okay. The assistant will guide you through this command that will be used within the training. So basically, the workflow will be import the files, parse the data, and split the data, and build the model, and make a prediction, and then save the model for the further use or inference. So let's start with our first example, which is the K-mean clustering. First, I don't need this. I just want to this cluster. We have a data set is a seed data set. The seeds data set will give you the geometrical properties of the kernels that we want to try to divide this data set into 3 different varieties of wheat. So first is we can do is import file. Click import file, and then I gonna copy the link here. Search. Oh no, this one. Let me make the copy. Copy link here. No. Yes, this is the data that's saved in here. And then I just found one data, add all, and actions gonna import. After we import the data, you can see the command is over here. You can just basically paste it in your one of your cells. I will paste here for everyone. And then we can parse these files. Parse these files, this seed data set, and the separator, we choose the correct separator. This is correct, and do this column data has a like a head column or something, which we do not have here. Everything is already shown as the numerical data, and then we will choose the number of column is 8, right? Now we're gonna parse it. So we parse the data. Now we read in the data as a hex file, and then we have the data set here. So there's 8 column. The first 7 column is real number, which is the geometry of the kernel of the weeds, the area, the length, the width, and some other coefficient. And then the C8, which we can see range from 1 to 3, is actually 3 different kind of data. Three of kind of the different version of the weed, right? And then normally we will split the data over here. So okay, the parse files will look like this. And then we will split the data. Split the data, we will have a ratio. I will use 75% for training and 25% for evaluation. So we do feed frames like this. And then I will create 2 separate frames. Right, there's 2 frames already been set. And then let's go back. Let's build the model. Build the model, you will select a algorithm. For the algorithm. Yes, is there any questions?
Yeah, so when the data came in, it was when we parsed the data. So sorry, I'm trying to understand. What did the parse do?
Just reading the data.
Reading the data, and then how did this create the mean maximum mean with it? So
this is after for here you parse this file here,
yeah,
and then you will automatically read in from the txt file into a hex file over here. So from here you will see the data being read in, and and also has the C1 column 1 through 8.
Yeah, this is what I don't understand. So what does this C1 to C8 tell us? Because we just downloaded a CSV data. There is a lot of different values, 8 columns.
Yes. So this column each represent a different feature of the kernel of the wheat.
Okay.
Like the kernel 1 is the area, column 2 is perimeter, okay. And column 3 is the compactness, and column 4 is the length of the kernel, width of the kernel, and several other coefficients. And the 8 is actually the label.
And where is it written? Where are you reading?
What?
Where is it written? Where are you reading that from? This header information?
This header information. I just you can. I will. Yeah, maybe I will paste it here.
So the question is what did we click and what command did we give so that it calculated the mean, max, minimum, and sigma?
So the calculation there is automatically done after you're reading the data in, which is in our case here is you can see this is before you parse the data is actually a series of numbers.
Right.
And then it will calculate itself.
Okay.
We don't need to do anything. It's automatically done.
So for any CSV data, this will calculate mean, maximum, mean, and
Yes.
automatically. Okay.
Yes, column-wise.
Column-wise.
Yeah.
Okay. Thank you.
Yeah, no problem. And I think we worry. Okay, algorithm. So then we will choose a algorithm here. We choose the k-means. All right. So the training frame, we choose the 75%, and that's the validation frame. We use the 25%, right? So which column want to be ignored? I mean, I don't think we want to ignore anything. Every column is useful information, and then we're gonna choose the cluster number k, right? We already know we have 3 different kind of the weight, so we input the 3 over here, and then we will choose the maximum iteration, where is here to 100. And I think, do we need to ignore? I think what we want to do is we want to ignore column C, because column C is the label. We do not involve them in the training. There is not a target, right? Score iteration, and then we build the kernel. Build the model. After the model is built, we're gonna see the result of this k-mean within the cluster sum squares. We can see the result is pretty good. The error rate is going down. This is the output. The model summary. Everything we can see is from here. That we want the maximum is 3 clusters, right? There's the rows is 161 data point, and we only use 6 iteration to achieve the best result, and so on. I mean, we can find a lot of validation metrics here or something, right? And then we can do export our data current model to next for the further use, saving in the space. And the next time you do not need to train, just import the current data for your further inference. And this is one case. And let's start with the second one, which is random forest. This random forest will use a internet advertisement data. This is a classifier to decide based on this web page, the URL, the image URL, then alt text, the anchor text, the word occurring. So basically, to decide if this web page is advertisement or not. So this one, we also have the data over here, and we'll input this here. So basically, we will do import files, and then paste this advertisement data, click the add, import it, right? And parse the file, read in, and also a CXV, a divider, a separator is the comma. And also we can see here all the variables are here. We do not need the column header. So we just parse it. Done with view. So we can see they are values read in. And then we're gonna try to split the data also. The frame, right? We create a different data set. And then we will build a model using the random distributed random forest. The training data, we're gonna choose 75. The validation 25. Right? Since those are all zeros, those gonna be ignored. We do not need these non-usable value. I think only 3 here. And then how many trees we want to create? 50 maybe too much. Let's make 10. And the maximum depth is the maximum branching allowed. And we do not fold and wait. Separator, stopping everything. We can see from here is that, is there any other thing I need to do? A response. Okay. So, there's a lot of, we don't need to worry about this. And we do need to have a responsible column, which is actually the very last column, 159. C159 is a yes or no. Is this is an advertisement or not? This response. Okay, here. The responsible column is the label or the target, and then we will building the random forest. By building this, we can see the result is showing here, the scoring. The error is, the loss is keeping running down. And there's the training, the validation already here. So also we can see the variable importance, which variables have a better weight for our final decision. So all the plots is automatically drawn for you. So this is very easy, very convenient for our users to, if you have a small data set, you do not want to write your code from scratch. So you can just choose one of supported algorithm and give a very quick running and to see if this method and this data to test the data quality, or also if which certain algorithm is means best, get better solution for your problem. And then the next part, I wanna show a very unique features for this H2O flow web UI, which is called the auto ML, auto machine learning. So the term auto ML, automatic machine learning, refers to automated methods for model selection and hyperparameter optimizations. So basically, it will use for you do not need to know if which certain algorithm can solve your problem. You also do not know which one has best result, which one has the best performance. You just says, okay, I have this data, and I think this several algorithm might be work. The module for RF for ref. Oh, okay, I think we can do that later. So let me just continue with auto machine learning. So basically, we just choose several algorithms that might work for our cases, and then the H2O will do all the works for us, trying to train the model with all the mass algorithm, and try to optimize the hyperparameter, and then find out our best model to choose, and we can to choose from. But I mean, there's no free lunch here, right? So automatic machine learning is slow due to it is very heavy workload. All right, so for this one, I will use files. So I will use the data that is quite popular, which is the iris data. By giving you, this is a classification problem, by giving you several features for the iris flower, you will classify if this flower belong to one of these three category. And let's start it. So this is when we read in the data from here, so we're gonna parse the data, very easy. And we can see the first 4 columns is the numerical value of each features, and the 5th column is actually the classification label. I'm gonna parse the data. View. So as we can see, it already helped us to convert this label to numerical values from 0, 1, 2, 3 different the types of the flower, and we just doing a frame. And there's seeding, and this random create this frame. But this is a very small data set. We just try to make the example very, very fast. So this is very small. And when we go, so it's only 150 samples. So let's say, I don't know which algorithm works for me. Let's run AutoML. We gave them a project name. We call it Iris. And then the training data set will be Iris. Look here, response is column 5, C5, which is a classification it's a classification label. And then the validation using this 25, blending frame, leaderboard, we do not need, unfold, just leave it to default. So here is that this one support 6 algorithm, general linear regression, and the random forest. The BGM is gradient boost, deep learning, stacked in symbol, and the XG boost. So if you know that a certain method is not designed for this, you can just exclude them out of the automation parts. And we want to ignore the C5 since this is a label. So when building the training frame, this is now we want to use. And then if we want all these, I think if we choose all these, they will be too slow. Let's ignore 3. We just use the first 3 algorithm. And then let's see, maximum runtime in seconds. Let's say if you want, you can run this for a very long time. They will try to optimize. Okay, is there any? Try to optimize the parameter and find out for each possible algorithm. But you can also, let's say, I do not have that much of time. I only have 300 seconds, maybe, right? So the rest, I just leave it to train. So right now it's starting to work. As we can see, they are using different algorithm set up with a different hyperparameter. Okay, it is done. So nice. We have our series of different algorithm with a different hyperparameter done, and this is actually getting how many? It's getting 27 of them. So it's so you do not need to like tuning the hyperparameter yourself. It's the best result obviously listed here. So we can see, wow, I mean, this is the blue dot is the training data, and the orange one is the validation. Seems all right. And we can see the standard coefficient magnitude. And let's see, what's the error? The total, this one being classified correct. This one have some errors. So as we can see, the result is pretty good, right? And if you like, you can check. This is general linear migration, which of course is perfectly for this kind of work. But let's say if we want to see something else, see this one. Okay, so this one also have its own result, and the variable importance, like which variable have the better impact effects for the model, and the result is look like this, and this is the training and cross validation, and this is the result. Everything is shown here. So that's pretty much what I have for this session. Basically, some introduction for basic machine learning algorithm, and how to use this very easy and pleasing web UI to train your own model. Yes, and since we're using the community edition, only CPU are supported, but for their commercial edition, they do support multiple GPUs, and which if you can try, you can, I think for educational researcher, for educational purposes, the company will give you 6 months for validation, but after that, they will need a payment for the renewal of the service. But the community already quite convenient. So that's pretty much everything I had. So is there, oh, okay. Is there any questions?
So how big of a simulation can we do here with whatever resources we have?
There is, I don't think we have a size limitation here, but for our hardware limitation, we for this training session, I reduced. If you started H2O flow, you will find you will have 16 CPU cores per session, and normally we will for our users to normal user use it, they will get 64 CPU cores. Along this 64 CPU cores, you will get around 100 gigabyte of memory. So as long as your job can feed in the 100 gigabyte memory, pretty much you will work.
And do you have an example for doing all these things with climate data?
Actually, I'm choosing these demo data set because they are small. I just want to do the job within seconds rather than hours. The climate data is I cannot find a very good data set with a very small size. I'm sorry, but yeah, if you have one, you want to try.
We have one. The thing is, it's really easy to visualize if we understand the data. So it's a very useful exercise, but to know the advantage of that and how useful it is, it becomes easy if I understand the data, what's going in. So that's what I was wondering. And we can provide the climate data if you can help. Maybe let us know how to feed in that kind of data. What kind of data do we need? Maybe we can crop the data for just a small sample size.
Sure.
So that understand the value of machine learning and different techniques that you shared.
Sure. I mean that will be great. I mean I think we can have a offline session for discuss this.
Sure.
And even we can have a Zoom meeting. We can work this together.
Perfect.
To figure out. This is. This H2O flow is quite capable. I think if the method is we choose the method right, I mean it is quite capable. It just the only thing is the performance is not good as we have the GPU support, but given time, it got the job done.
And is there I'm trying to understand, is there a limit on number of variables or like two-dimensional variables that you are entering? Is there a limit on that that we can enter through into H2O?
To H2O, I'm sorry.
So we enter the raw data, right? So I saw
yes.
Raw data was a two-dimensional kind of an array that went in. So is there a maximum limit of the cells that it can handle?
I think they will have one since it's since the hardware for the hardware limitation, but I haven't tried that yet. I haven't tried a very large data they can now read in.
Okay, maybe we can. Maybe we can take offline, and maybe I just want to understand.
Yeah, maybe we can give it a try. I haven't tried a very large data set before. I mean, normally I would just use this hundreds of lines of data just to show the result.
Okay, thank you.
Yeah, no problem.
This was very useful. Thank you very much.
Yeah, no problem. Thank you. I mean, thank you for joining us today.
Is there any other questions? Okay. Yeah, so this tool is deployed on the system and everybody is welcome to use it. Okay, if there are no more questions, Dawei, thank you very much for this very informative presentation and the demonstration of the tools. So with that, we will conclude today's tutorial and we will continue next week. So as usual, this tutorial will eventually appear on our website. The recordings of this tutorial will appear there, so you can review it at a later time. Yeah, so Dawei, thank you very much.
All right. Thank you, everyone. Bye.